Assalamu alaikum, my name is Aroosa Saleh and I'm from Martindale, Calgary. My science experiment is whether water can float on water. Table of contents. Introduction, background info, experiment, layout of project, results, our findings, conclusion, what we learned. Introduction. Thermohaline circulation is deep ocean currents that are driven by differences in the water's density, which is controlled by temperature, thermal, and salinity, haline. In polar regions, the ocean gets very cold, forming sea ice. The surrounding seawater gets saltier as sea ice forms because salt is left behind. As salt concentration rises, density increases because the salt molecules can occupy spaces between the water molecules. Surface water is pulled in to replace the sinking water, which eventually becomes cold and salty enough to sink. This initiates the deep ocean currents driving the global conveyor belt. This is a diagram showing thermohaline circulation. The scale below shows salinity levels in different areas of the map. Experiment. The goal of this project is to investigate what happens to layers of water with different densities caused by temperature and salinity. The questions are, how does the temperature and salinity affect the density of water? The effect on our experiment. In nature, where are places that waters with different temperatures or salinities meet? If the temperature of water affects the density of water, then the layers will float on top of each other because warm water is less dense than cold water. If the salinity of water affects the density of water, then the layers will float on top of each other because salt molecules take up space and increase water density. Manipulated variable, salinity, temperature, responding variable, density, controlled variable, amount of water or freshwater density, the control, baseline to compare results to, freshwater. Materials. Table salt, you will need table salt and measuring teaspoon, food coloring, at least 2 different colors, hot and cold water, a hydrometer, a thermometer, 1 cup or glass, make sure it's wide enough to see the colors properly, a syringe or eyedropper. Procedure. Fill a large cup with room temperature water, ours was 20 Celsius. Measure the density using a hydrometer. Pour some of the cup water into a tinier cup. Add drops of food coloring. Take a syringe and fill it up with colored water. Put drops into the large glass. Continue adding until you are satisfied. Record your observations. The next part is for the salinity experiment. Repeat step 1 to 4. Add about half a teaspoon of salt. Measure the density using a hydrometer. Repeat steps 5 to 7. Procedure, hot and cold water. Fill a large cup with room temperature water. Measure the density using a hydrometer. Pour cold water into a tinier cup. Make sure the temperature is lower than the room temperature. Ours is at 10 degrees. Add a couple of drops of food coloring. Take a syringe and fill it up with cold water. Add a couple droplets of the cold water in the large glass. Observe what happens. Repeat steps 3 to 5 for warm water. Make sure the temperature of warm water is higher than the room temperature. Ours was 61 Celsius. Use a different color than the cold water. Also, before you start this, make sure that you measure the density of both the cold water and the warm water. Results. The first photo shows how we added the colored water into the full cup. The last photo is of the thermometer reading, which is at 20 Celsius. As you can tell, the water droplets that we are putting in are slowly moving towards the middle. As you can tell, the top photo on the left side shows the tinier cup and the bigger cup with the thermometer. The photo below shows the hydrometer, which is 1.033 for density and 43 for salinity. The middle photo shows how we added salt water into the full cup. In this experiment, we are putting colored salt water in fresh water. It is sinking to the bottom. The top left photo shows the thermometer reading in cold water at 10 degrees Celsius, the red, and the hot water at 61 degrees Celsius, the green. The second photo on the right shows the hydrometer readings. The clear water is the cold water. The density is 1.016 for cold and 1.008 for warm. The third photo shows the cups and the syringes. All 3 photos show the gradual addition of the mixtures into the full cup. The first is cold water, the second and third is warm water. We took a break between the second and third to allow for the mixtures to mix. Here are 2 videos. As you can tell, within seconds, the cold water is going to the very bottom of the cup. Now, we are going to be putting the hot water. As you can tell, the hot water is floating on top of the cold water. This is because of the density. As you can tell, in the extra part of the experiment, the purpose was to test if the water levels would rise or stay the same if the ice was placed in it. In the fresh water, the liquid level stayed the same. The entire volume of solid ice that was above liquid level got compressed because of the density changes as the water turns back into a liquid. So here it shows the water levels. In the salt water, the liquid level rates considerably higher. Salt water has a higher mass than fresh water, so it's a little more dense. When the fresh water melts, it decreases the salinity of the ocean. Less salt equals less dense. It's because of this that the volume of the salt water expands when the fresh water sinks into it. So here it's showing the water level. And it's showing how it's rising. Conclusion. Findings. First experiment, fresh water. Density in the syringe is equal to the density of water, so it floated in the middle. The density is 1.006 at 20 Celsius, which will remain constant in all the experiments. Second experiment, salt water, using 1.006 at 20 Celsius. Density of salt water is 1.033 and the salinity is at 40. The high density of salt water led it to sink to the bottom. Third experiment, first part, cold water. Density of cold water is at 1.016 at 10 Celsius. Cold water's density was higher than fresh water, so it sunk. Third experiment, second part, hot water. Density of warm water is at 1.008 at 61 Celsius. The warm water did not rise on top of the fresh water. Rather, it sank and floated on top of the cold water. This is because it was more dense than fresh, but less dense than cold. In nature. The Dead Sea. The Dead Sea is the middle of the desert, surrounded by Israel, the Palestinian West Bank, and Jordan. It's called the Dead Sea because nothing can grow or live in the water. It is in the lowest valley on earth and landlocked. All the minerals and salts from the surrounding waters flow into it. It's 9.6 times saltier than the ocean, 34% salinity, mostly at the bottom of the lake. A person's body weight is lighter than the density of the salt water in the Dead Sea, leading to natural buoyancy. The further you weigh, the more you'll experience the feeling of being pushed up, which makes swimming here impossible. Melting glaciers. Density differences between salt water and fresh water result in a difference between the volume of seawater and the fresh water. Ice melts faster in salt water because salt water has a lower freezing point than fresh water, so the ice will have to absorb less heat in order to melt in the salt water than in the fresh water. Both thermal expansion as the water warms, the volume increases, and ice melting are the results of climate change. In conclusion, I have learned a lot from this experiment. I have learned the importance of buoyancy, the effects of climate change, and the effects of temperature and salinity on density. I also got to explore places where this phenomenon is happening constantly. Jazakallah for your time. I hope you enjoyed my project.